Hello scholars, welcome to day 3. I just want to point out that if at any time you think it would be convenient to have access to your Algebra 2 textbook, you should still have access to your Algebra 2 textbook. I think even if you weren't in my class last semester. So you could go to bigideasmath.com, choose log in with Clever. You might have to choose Reseda Charter High School out of the list, and then log in with your MyMail account, and you'll have access. We have 2 big jobs today. One is to talk about how to draw a histogram, and the other is about how to draw what's called a box and whiskers plot. So 2 different ways today about how to take a data set and turn it into a picture that somebody could use to kind of get a really fast, big idea about what's going on in the data. So we'll talk about how we can use histograms and box and whisker plots to think about measures of central tendency and think about measures of spread. So I'm starting with this example, which actually comes from the Algebra 2 book. I took some data, I walked into the gym, and for all the people who were in the gym at that moment, I asked them what their age was. And then I have what's called a frequency table. A frequency table. It tells you, it's sort of got categories for ages, where ages come in ranges. Notice all these ranges have the same width. So like a 10-year range. So people from 10 to 19, from 20 to 29, from 30 to 39. And I counted the number of people who fit into each group. So there were no people in their 50s, but there were 3 people in their 60s, there were 6 people in their 30s, and I have this data. So I want to be able to turn it into what we call a histogram. So your textbook has done this for you. I'm just going to point out some features before I show you the process I would use to make that. No space between bars, and if there's a category, in this case people in their 50s, for which the data happens to be 0, you still have to leave a space for it. Otherwise, if I had taken this bar and scooched it in, somebody who was just glancing might not notice that there was a gap. There's no people in their 50s. So I have to leave a space for them. So I'm going to think about this table. I notice my category that had the most people in it is people in their 20s. They have 12 people. I have a category of 0. I've got to get from people in the 10s to 19s all the way up to 60s. So I'm going to show you the process I would use to make that graph. Now you don't need to use graph paper, but I thought it might be nice to use graph paper. So for me, what do I have to make sure I fit? I need to fit 10s, 20s, 30s, 40s, 50s, and 60s. So I need space for 6 sort of categories along my, what would normally be the x-axis. It's customary to make them the same width. So this is people at gym sort of organized by their age. My axis here is frequency. I want to make sure I get all the way up to 12. So do I have enough space? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the 20-year-olds are going to have to go all the way up there. So this is for 10 to 19-year-olds. There are 7. So I'm going to make this bar 7 spaces high. For 20 to 29-year-olds, there are 12 of them, so I'm going to make this bar 12 spaces high. That was all the way up here. People in their 30s, so that's 30 to 39. There were 6 of them, so I'm going to make this bar 6 spaces tall. So there's nothing special about how wide I made the bars, but they should all have the same width. There's nothing special about whether I counted by 1s. I could have counted by 2s. But this graph, once I make it, gives me an idea of the relative numbers of people by age. So when I look at this graph, I see, oh, like people in their teens and 20s was like the peak. And there were some people in their 60s, but it was definitely a lower down space. That gives me the idea that there were fewer people in their 60s at the gym. So you might, just for practice, like to think about, so either do or think about, do you think you could turn this, we call it a frequency table, into a histogram? And if you have any questions, a good time to reach out and make sure that your questions get answered. Because if you have any trouble with this, wait till you see what this looks like in the Precalculus book. So this was the Algebra 2 book. Gave you the table. You could tell these categories. We call them buckets sometimes because it's like a wider range for a data value to fit into. So I'm going to group together all the people in their 20s, group together all the people in their 30s. We're already kind of designed for you. Here we go to your Precalculus book. So here in your textbook, we start with this section called Organized Data. We're not going to get a nice frequency table and have to turn it into a histogram. We're going to get this long list of football scores. It's going to be our job to decide how many buckets should I use, how wide should the buckets be. I'm going to be in charge of counting up all the data values and deciding which bucket they fit into, and then turning that frequency table into a histogram. So some words to know. Those categories we call classes or intervals. And the class width is how much distance, like mathematical distance, there is between the lower limit and the upper limit for class. So like in that last problem we did from 10 to 19, that is a class width of 10, lower class. So watch what happens in this example. We have 42 Super Bowls have been played by the time your textbook got published. And these are the winning scores for those 42 Super Bowls. Can we make the frequency table? So can we look at this? It's our job to notice what's like the lowest score here. I see a 14. Highest score, here's a 48. Oh, here's a 55. 52. So we have, at least when I just scan through, I see a 14. I have to get all the way down from 14 all the way up to 55. It might be appropriate to use buckets that have an interval like a class width of 10, just like we did in the ages problem. I'm not saying that every bucket and every frequency table you make is going to have a width of 10, but sometimes it makes sense because we kind of think about numbers like that sometimes when we're thinking because of our base 10 system, right? So here's what I would do. I would make this chart and I would list these buckets. And then I would walk through the list and I would say, okay, well, the first score was 35 and I'd put a tally in the 30s. And then the next score was 33, I'd put another tally in the 30s. And 16, I'd put my tally mark here in the 10s. And I would keep going until I'd made a tally mark for each score in my data set. Once I do that, I can count up those numbers. And if I think about this, then this column combined with this column is like what I had in that first example we started with. This is our frequency table. So two things I might do from here. I might make the relative frequency table that I made in the last example we did. So that's like this. Here's my histogram. These are my buckets. And let's see, there were 5 scores that were between 10 and 19, so I have a height of 5. There were 16 scores in the 20s, and so this has a height of 16. And I make my histogram. This is a frequency distribution histogram, just like I made for the people at the gym in that example we started with. I could also make what's called a relative frequency histogram. Notice what happens here. The shape is exactly the same, but instead of making my heights of the bars the number of data points there were in that category, I make it according to the relative to the whole. So there were 5 scores that were in the category 10 to 19, and there were 42 total scores. So 5 divided by 42 is 0.12. So that's the height of this bar. This is a height of 0.12 because that's 5 out of 42. The second bucket, the 20s, had 16 out of 42. 16 out of 42 is 0.38. So you can see the height here is 0.38. So this is a way, this is going to be a big topic for us. This is a way to help the data be visual, but then also take away from it its dependence on these specific numbers. So the fact that there were exactly 5 and exactly 16 numbers in each of these buckets. Now, if I just wanted to compare it to all the data I had, so again, notice the shape is the same. It's just my scale on my vertical axis is different. Here, it's a percentage, a fraction of how much the data in this category represented from the total amount of data we had. So one more variation on that on the histogram, you could make what's called a cumulative frequency distribution. So instead of saying 5 scores were from 10 to 19 and 16 scores were from 20 to 29, you can add them up. So cumulative, meaning accumulate. So you're going to add together all the values as you go from left to right. So if you're thinking about the first bucket, there are 5 scores in the first bucket. Let's see. When you get to the second bucket, you're going to count not only the scores that are in the second bucket, but include in it the scores from the first bucket. So that would be 5 plus 16 to make 21, and you make that second bar 21 high. So that means the bars in this kind of histogram can only get taller. And by the time you get to that last bar, the last bar's height should be the same as the number of data items that you had in your list. So, so again, cumulative frequency distribution. That's what we have here. So this is a cumulative frequency table because these numbers are added together. So 5 plus 16 to make 21. Add 15 to that to get the 36. And then this is the histogram to go with that table. So a cumulative frequency histogram.